In this tutorial, we're going to have a look at applying suvat to this past paper, which is May 2011. The reason I've chosen this particular question is because it's only got vertical motion, which means we don't have to have extra time wasted on vectors, but the principles can be applied either way, just by applying the rest of the rules. Okay, so the first thing we need to realize is 9.81 for G, which is from the data book. 3 sig figs. Okay, the next up is we would write suvat in, and this is a system that works every time, so you need to adopt this. Now the suvat system with the columns means that you can quickly find out which variables you have and don't have and select the correct formula from the book without having to get right down to the end of the line and realize you've got too many variables and not be able to find the answer. So let's have a look at how this is going to work. The S is going to be the question mark because it says here calculate the maximum height reached by the ball or whatever it is, stone. Okay, U is going to be the initial velocity, which is already vertical, so it's an upward component. So let's put that in there, 15. V, you may not think you know that, we're going to come back to that in a minute. Time, we don't know it, but we're going to put a small question mark because we're probably going to need it later on. You nearly always need time somewhere along the line. Okay, acceleration is 9.81, we've already said that, let's put that in there. And V, we're going to talk about that right now. With projectiles, if the woman is throwing the ball, the point at which it stops is its peak height. Okay, so your maximum height, vertical displacement, is at when velocity equals 0. So we can safely say that velocity equals 0 in that position, the maximum position. So we need to find S. Now the way to do this is to take note of the variables we have and then the variable that we need and then find the correct formula. I'm going to use number 3, suvat 3. Let's just write that out for you from this. V squared equals U squared plus 2AS. Okay, right, this is fairly easy to do. We're going to lose one of the terms already because obviously V is 0. So when we rearrange that to make S the subject, we end up with S equals minus U squared. The V's gone because it's a 0 over 2 times minus 9.81. Now in the booklet it says 9.81, but because it's a vector they only give you the modulus and they don't say that, it's misleading. It's actually minus 9.81, and that makes the distance come out right with the right plus or minus. So if you ever get stuck with that, it's because of the minus on G, because it's going downwards. So that gives us an answer of 11.747 meters. Let's put that in there. S equals 11.47 meters. Now in the exam I would expect you to put the right numbers in the formula after you've rearranged it as well, and everything should be in this box as well, but unfortunately I don't have the room. So that would round to 12 meters, but I'm going to keep the 11.47 because I might need it in a minute anyway, and I'm quickly going to find out time as well, which I'll do on the side. Time is another thing we can find out because we've got 3 variables, but we just need to select a different suvat, which is going to be suvat 1, which is V equals U plus AT. Okay, so we've got obviously V is 0, so when we rearrange that gets rid of one of the variables, and we end up with T equals minus U over A, which again cancels the negatives to give us a positive value, which is what you'd expect, and we end up with 15 over 9.81, which is in the region of 1.5 seconds. That's the time from her hand to the peak point. So on to the next one. That's not actually the question, but it's very useful for later on. Okay, next up, Determine the time for the stone to reach the surface of the sea after leaving her hand. So what you've got to realise is this. The path of the stone goes from her hand back to where the hand started and then plummets down 80 metres lower down the cliff. So what we have is a brand new suvat, and the way I'm going to do it is put 1.5 seconds here. Now we know that's another 1.5 seconds, but just for directness, I'm going to just ignore that, and I'm going to put the distance or displacement of 11.47 meters in there, and you'll see why in a minute. So I'm going to say time total, let's change pens, time equals t up plus t down to the sea, and what that is 1.5 plus a whole new suvat. So the whole new suvat is this. I'm going to write it up here. Okay, we need time. We definitely want time this time. We know the distance. That's going to be 91.47. I'm not going to round it because I think we can do the rounding at the end. U, the initial velocity when it starts here is 0 because it's at the peak point. So we've got a 0 there. The final velocity we don't know. The acceleration is 9.81. So let's change colours. So we've got A, we've got U, we've got S. So we have to go through and find the correct formula with those variables from the data booklet. Okay, just to recap, we're trying to find the time taken to get from the peak point all the way down to the water. We've got a distance of 91.47 meters. We've got a U of 0. We don't know V, and the acceleration is 9.81. So the correct formula for this is going to be suvat 2. Just write that in there. I'm going to have to put it over to the right. S equals ut plus half AT squared. U is 0, so that's nice, gets rid of that. So we end up with S equals half AT squared. If you make T the subject, you end up with T equals the root of 2S over A. Okay, so that's nice. We can just stick that in, and then the time. So I'm going to put plus there, because you already got the first one, and then 2 times 91.47, root in there, 2 times 91.47 all over minus 9.81, and there's also the 91.47 is actually a minus 2 because it's going downwards. So we end up with a value of 4.32 seconds, two significant figures. So we add the two together, time up plus the time down, which gives us a time from the hand to the sea of 5.8 seconds.